from volumes of solids with known cross sections to volumes created by rotating something around the x-axis. That's what we're going to be learning how to do today. So, if I take something like this curve here, you had a question that kind of asked you this on your homework last night, so an extension question on your homework. And I take it and rotate it around the x-axis. Wouldn't it create, if I take it, swing it around the x-axis, wouldn't it create kind of a bowl shape there? Everyone see it? So we rotated this around. Rotating it, swinging it all the way around the x-axis, creating a three-dimensional shape. Does everyone see it? That's the hardest part of being able to see it. You can see these. The calculus is not that difficult, but being able to see what shape we're getting is the hardest part. Does anyone not see it yet?
Yeah, I saw it. I thought that was still in the area.
You see it? Okay. Now, if that is the solid, and I opened it up and showed you a cross section, what would the cross section be? Would everyone agree it's a circle if I'm rotating?
So it's going backwards as well?
It's going
Yes, all the way around the x-axis. Swinging all the way around. So, it would create a bowl-shaped object, and our job is to find a volume. But it turns out that it's really just another question like yesterday, where we have a cross-section. We need to find the radius and volume. By the way, what is a little different about this problem and the circle or semicircle problems from yesterday? What is the radius? It's the whole distance, isn't it? Because the radius of this circle here is that distance. So that we're still going to use pi r squared, but now our radius is that also. So, whenever we revolve an area, we create an object that has circles for cross sections. There are an infinite number of those circles. They make a 3D shape. We can use an integral to add up all of those areas of the circles to get the volume. This probably sounds a lot like what I said yesterday, right? So most textbooks actually teach this before they teach what I taught yesterday. I like it the other way first because to me I like to go more general first and then more specific. This is really just another case of what we learned yesterday. So we're going to integrate the area to find volume. So the volume is going to be pi r squared dx if we are rotating around the x-axis. If we are rotating around the y-axis, would you agree that our circles would then be perpendicular to the y-axis? If we rotated vertically? So then we will have dy. Any questions about that so far? Everyone is here today, right? This is known as the disk method because all the cross sections look like this. Math people were known for our creativity. They're your notes. Okay, so this is a little video. Okay, so we start with a shape rotated around the x-axis. Now I put this up here because my 3D drawing skills are limited. So this kind of gives you an idea of what's happening. Going back behind the x-axis and rotating it around. It is a each cross section is a circle, and for the volume of that solid would be pi times whatever the height of the function is, which would be f of x squared. So the integral would be just a little picture of what's happening to help your brains out a little. Sometimes there will be a hole in the middle. So sometimes when we rotate, we don't get a solid figure, we get something with like a donut, right? It's got a hole in the middle. So we need to find the volume of the donut. So if we have a shape that has a hole in the middle, instead of using discs, we're going to use what are known as washers. Does anyone know what a washer is? Those of you who have built anything.
Those little circles.
Yep, it's a little circle with a hole in it. You put it. Yeah. I used to have one in my classroom. I need to get one again so I can show you what a washer looks like. So it's a circle with a hole in the middle. How do you find the area of a circle with a hole in the middle? You take the area of the whole circle minus the area of the little circle, right? So you do pi r squared minus pi little r squared. Well, the simplified form of that is pi times capital R squared minus little r squared, where the little r is the inside radius and the big R is the outside radius. Obviously, if we're rotating the other way, we will use dy. Other than that, the formula is the same. So the washer method, we will have an outside radius and inside radius. Any questions about that so far? So, if we start with a area that is bounded between two curves, and then I go to rotate it around the x-axis, then I have a face that has a small inside or something like that, right? It turns out a little different. Each cross section is a washer, so if you didn't know what a washer looked like, now you do. So each cross section is a washer. The area of a cross section would be pi times the height of the big curve squared minus the little curve. Pi times the little curve squared. And so you can factor a pi out to get those formulas up there. Or you can leave the pi, multiply m, and leave the formula like that. Either way. Right. Just to make the calculus easier. Just get rid of that concept. Not, it's f of x squared minus g of x squared. Is that the same really quick as f of x minus g of x all parentheses squared? So be careful, don't do that. Okay, so steps for doing anyone didn't get one, let me know. If there is a gap, this is an important step. If there is any gap in between the region and where I am rotating it around, then I will have to use the washer method. If there is no gap, I will use the disc method. So if there's a gap when I rotate, I'll get a washer. If there's not a gap when I rotate, I'll get a disc. So there won't be a hole in the middle if there's no gap. So, time out before we keep writing. I just want to show you a picture of what those last two steps mean. See on this region, remember the region was this little area here? Right? There was a gap between that and the x-axis, so that created a washer shape. On this region back here, there was no gap, so that created a disc. So that's what that means. Identify capital R and lowercase r. On the washer method, just identify capital R if you're doing the disc method. And you're pretty much done. Did you get it? Yeah. I checked it real close.
I checked it real close.
What? Speaking of, we can probably generate the volume of film formula.
Next, we have found donuts. We can do a donut out here.
Like a gallon of donuts.
Whenever they first made first donuts.
Like, whenever they first they
They're all perfect. They're all exactly the same. I had to do something.
Yeah, we're supposed to listen to it.
Yeah, they're
Now, I will tell you, this is how, remember that story I was telling you about my husband's friend who is an estimator for a construction company? This is the process I had to go through to help him, because his shape was making a fountain. It was kind of curved round. So it was
How big was this fountain?
pretty big.
Like, $6
Just out of the kindness of my heart.
I should and willing to one day during lunch run to go get a box of donuts so we can all do this. Find the whole area of an actual donut.
I'll get you but you're done.
We're gonna do it with a Hershey's Kiss.
Close enough.
On the day we do the Hershey's Kiss project, you could just bring us donuts.
Do that.
Yeah, we can eat the donuts and have volume of a Hershey's Kiss. I'm totally okay with only finding the volume of a Hershey's Kiss and eating the donuts. What is it? Okay. Example number 1. Find the volume of the solid created if the region bounded by the square root of x, y equals 0, and x equals 3 is rotated around the x-axis. thing I'm going to have to do is draw that shape. A lot of times on the AP exam, they will only make you set these up. A lot of times they won't even make you integrate. Sometimes they will. Depends. Sometimes they'll give you the picture if it's hard. If it were this one, they might make you draw it yourself. Because it's a square root of x, so they'll expect that you can graph that. But it would be basic things that if you have to do it, if you have to draw the picture. X equals 3. And the x-axis. This is my region. First thing I'm going to ask myself, is there a gap between that and the x-axis? No. So, is it a disk or a washer? It's a disk, because there's no gap between region and the x-axis. And I'm going to go ahead and draw this part of the picture. Some of you will need to think about the rotation. Others of you can probably do this without drawing the rotation. But I'm rotating this around the x-axis. So I'm creating a shape that looks like this, right? So my cross sections are circles. So my area is pi, and they put the pi in front. It's just nice to get it out of the way. Times the radius. What is the radius? Square root of x. Everyone agree? It's the height of that curve. Square. Yeah. From where to where? 0 to 3. Any questions about that? This is a by hand problem, probably, right? Because what's the square root of x squared? And do we know how to differentiate x?
Yes.
No way. X squared.
Squared divided by 2, right? From 0 to 3. So you could do this one by hand. Like for today, I'm going to skip those integrals just so we can set up as many as possible. Practice your integrals. What? Yesterday you were. Yesterday you were bad.
We were just nervous because
I don't even think that's what you can be in here. I'll give you that. Maybe you were nervous because so his presence makes you forget all. Is that what it was? Ouch. Okay. Find the volume of the solid created that same region. So I'm going to, same region, right? But this time I am rotating it around the y-axis. Is there a gap between that region and the y-axis? Yes. Do you see how it doesn't sit flush with the y-axis? Right? So there's definitely a gap. So, right? We're getting this region. Who knows?
No, it's one of those like words or changes. You know, do you remember those words? Like it had like the little difference.
Or could be some kind of motor.
Or that.
Anyway, whatever it is, the cross section of it is a washer, right? The cross section is a 2 circles, right, or a washer. And I'm integrating dy. Why dy? Those cross sections are perpendicular to the y-axis where I'm rotating around the y-axis. So, I need the radius of the outside piece. Remember, I do need to be in y terms. But what's the radius of the outside the whole time? Does everybody agree that radius is 3? Where along that curve I am, the radius from here to here is 3 units, right? Okay, so that's my big radius. What about my little radius? Okay, it is changing, and it's the distance from 0 to that square root curve. But I know I can't use the square root of x because I'm integrating dy. So I need to change this into a different, so y squared is x. And so the distance from 0 over to y squared, you could do y squared minus 0 if you wanted to. It would be a little unnecessary, but you could. Right? So minus y squared, that's my radius, right? So I still need to square. Any questions so far? Am I still 0 to 3? Probably not. Why 0 to the square root of 3? I need the y value when x is 3, right? Because I need to go from here to up here, wherever that is, which is the y value when x is 3. So square root of 3 is 3. Again, this is a problem you can anti-differentiate by hand if you wish. Again, for today, I'm going to skip those just because I want to do as many examples as possible. Yes? Okay, so I knew this intersection happened at 3 for the x value. What's the y value? So square root. So I needed the y value of that intersection. Okay. I have a region here, and I'm going to rotate it around a lot of different things. And I have some pictures of some of them that I used the computer to generate. Find the volume of the solid created by revolving the area between those graphs around different lines. So the first one is around the x-axis. How many of you kind of like these? Yeah. Okay, so I'm going to rotate around the x-axis. Is there a gap between the region and the x-axis? Well, what's the region, first of all? That thing, right? Is there a gap between that and the x-axis? Yes. So what does that mean? It's a washer. Do what?
Rotating it around the x-axis.
We are rotating it around the x-axis.
Does it even look like anything?
This is the picture, a 3D picture of this rotated around. Yes. Well, it's kind of turned sideways so you can see it. Can you turn that light out for just a second? Hold on. The light first. Okay, so see it's rotated around. This is the x-axis coming this way. So this is the region. This is the region. And they rotated this region around the x-axis. It is kind of good looking. Okay. Thank you. Okay, so I want to, so I'm going to set up from, I know I'm using washers, and I know that I'm dy or dx. Y dx. I'm rotating around the x-axis, so my cross-sections are going to be perpendicular to the x-axis. In horizontal rotation, you're going to get perpendicular to the x-axis. So if I am spinning this thing around, this thing around. So I have an outside. So on each place I have an outside and an inside radius, right? I have a little washer in here. You will. It will be part of the. Little washers all along there. Okay. What is the outside radius? The x plus 2 minus 0. Everyone agree it's this distance outside radius? The radius of the outside of one of those washers is x plus 2 minus 0. If you want to write minus 0, but x plus 2. Any questions about that? The outside radius. Everyone see that? Okay. What about the inside radius? Yeah, it's x squared minus 0. Now, I heard a couple of you say that in parts this is not a washer. Is that true? At 0, you're right. At 0, you're subtracting 0. But does this work out to do that for you? So it takes care of that, yeah, at some places we touch, but most places we don't. There's in fact only one point at which we touch. So this will have a closed-in spot in the middle where it won't have a washer in it. Okay, any questions so far? Yeah, something. I don't know what it is. Any questions so far? Okay. What are the endpoints, and how will I find them? I need the intersection.
Staff, please excuse the interruption. Any high school students who have junior high classes need to report to study hall tomorrow. You will not report to the junior high. You will report to study hall during that period tomorrow. Also, all library fines and overdue books are to be taken care of before tomorrow morning. Thank you.
Negative 1 and 2. I did this by hand. You did this with calculator. Probably could use the calculator.
For R, we still did these are
Most of the time, now be careful if it's, but yes, you're looking for that outside radius. Sometimes it happens. So this radius here is all these circles. So you see these big circles I've drawn? I want the radius of all of those big circles. Okay. Any questions about that? Okay, let's look at the next one. And this is the first time we've ever rotated around something other than x or y axes. I want to rotate this around the line y equals 5. For whatever weird reason I want to do that, I want to do it. Before I start, is there a gap? Yes. There is a big gap. So this is definitely a washer problem. Don't like that, Walker? Is it still a horizontal rotation? So it is still dx, even though it's not around the x-axis anymore. It's still a rotation, like a rotation around the x-axis. I'm still integrating from negative 1 to 2 because my region hasn't changed. Everyone know what I mean by that? This is still the region that I'm rotating. But this time I'm rotating it, and you will have to forgive my lack of drawing skills. A lot easier to do on paper. Here, I rotate it around. You see it? I think I went a little too high. Does everyone and see what we're doing, rotating it around the line y equals x. So, let's talk about the outside radius of one of these big circles. So, would you agree that the radius is from here to here? I'm not going to go up there. I had to draw that. I didn't do a very good job. So I'm going to use the part I know. Everyone know what I mean by that? I stick with the part I know. I don't want to create new curves to have to use to find a radius on it. So I'm going to stick with what I know. So the outside radius is the distance from here to the bottom part of this parabola. Would you agree? From here to the bottom part of that parabola. Let me draw another big circle. Does everyone agree? So where's here? 5. And where's here? Squared. So that distance would be 5 minus x squared. So I want to stall for a minute. You get it?
Yeah.
You check it close. Okay, any questions so far? Any questions so far? I'm stalling because I know that's a tough one. Anyone not see where I got the 5 minus x squared for the radius of the big circle? Everyone sees it? Okay, inside circle. So this blue circle here is an inside circle, right? This one, what is the radius of it? 5 minus whatever that thing is. And what is that thing? X plus 2.
Well, it would just be x minus 2, wouldn't it?
But it would just be negative x plus 3. Make sure that you do put parentheses around the x plus 2. You do need those parentheses. Any questions about that one? Good? Okay. So the outside circle, which is this black one, so we're going to do the radius of it. Okay, got the black one. Okay. So the blue one, this blue circle here, the radius is the distance from 5 to here. Okay. And to get distance, we always do top minus bottom or right minus left. Are you sure?
Yeah, I get it.
We do.
Around the y-axis.
Instead of like 3 to 3. Fair enough. Okay, we'll rotate around x equals 7. So I did skip one, I'll do it tomorrow. We'll do more examples tomorrow. So, 1, 2, 3, 4, 5, 6, 7. So we're rotating around that line. This is the picture. Shelby wanted to come light up. Just 2 seconds. Let me see this picture. So you see this rotation around the line x equals 7. Let's see how that picture shows out. So I'm rotating, and I get. So would you agree this will be my outside circle, and this will be an inside circle? Okay, let's go all the way straight. 6. Okay. So since I'm rotating around a vertical line, what is my equation? dy. Is there a gap?
Probably.
Definitely one of the day. Why is it so bad?
Because you have to do 2 intervals.
Would you agree that as I move down here, my outside circle is on a different curve than it was up there? Does everyone agree my outside circle is on a different curve? So we've got to actually break this up into 2 pieces. Both washers, but 2 pieces. What 2 pieces? 0 to the first intersection, right? 0 to, it looks like 1. I think it is 1. Y value. And then from 1 to 4, is that right? 0 to 1 and 1 to 4. Because we got 2 for the x value of it, right? So x squared is give you a 4 for y.
Oh yeah, you have to do it.
So what we're really doing is breaking this up into 2 different volumes. We're finding the volume above the red line and a volume below the red line, right? So below the red line, my outside radius, what is this value? This distance. From here all the way back to there. 7 minus this side, right? What side is that? It's the plus or minus. Well, which side is the left? The minus, right? And doesn't that make sense? Isn't it 7 plus a little bit? Not really 7 minus a little bit. But it works out. So we probably won't finish the problem. That's